Hi everyone, let's talk about some trigonometric identities. In particular, we're going to be talking about the double angle identities and the half angle identities. To derive these, we're going to need the addition identities for sine and cosine. So let's write them out. For sine, it's the following. Sine of x plus y is equal to sine x times cos y plus cos x times sine y. For cosine, it's cos of x plus y is equal to cos of x times cos of y minus sine of x times sine of y. Now what we're going to do is we're going to substitute in x equals to y, so we get double angles. So what we get when we do this is that sine of 2x is equal to sine x cos x plus cos of x sine of x, and that's just equal to 2 times sine x cos of x. So that's the double angle identity for sine of 2 of x. For the cosine of 2 of x, we can use the same procedure, but we're going to do something extra that you'll see in just a moment. So cos of 2 of x is equal to cos x minus sine x sine x. So that's equal to cos square x minus sine square x. But because of these squares, we can apply the Pythagorean identity. What it says is that sine square x plus cos square x is equal to 1. And that tells us two things: that sine square x is equal to 1 minus cos square x, and cos square x is equal to 1 minus sine square x. And now we're going to use those over here. So this is the first form, but there are two other forms that we can use. We'll call this A and this B. Using A, we get that this is cos square x minus 1 minus cos square x, and that's equal to 2 cos square x minus 1. And we also get that it's equal to 1 minus sine square x minus sine square x. That's equal to 1 minus 2 sine square x. So we're going to call this 2 and this 3. So there's 3 ways of writing the cos of 2x identity. So now we know the identity for sine of 2x and the identities for cos of 2x. And we're going to use the cos of 2x identities to derive the half angle identities. What we're going to do is use a substitution. We're going to say y equals to 2x, which is equivalent to x equals to y over 2. So what that tells us is that cos of y is equal to 2 cos square y over 2 minus 1 is equal to 1 minus 2 sine square y over 2. And now we're going to isolate cos square and sine square. So we get that cos square y over 2 is equal to cos of y plus 1 over 2. And we get that sine square y over 2 is equal to 1 minus cos of y over 2. We can actually write this as 1 plus cos y over 2 so that it's similar to the other one. Now you might be wondering, can we get rid of these squares? And the answer is yes, you can get rid of the squares if you know the quadrant in which y over 2 lies. So cos of y over 2 is equal to the square root of 1 plus cos y over 2, but you have to put a plus minus there. And sine of y over 2 is equal to 1 minus cos y over 2 square root, and you have to put a plus minus here as well. And whether it's a plus or minus is going to depend on the quadrant in which y over 2 lies. And you'll have to figure that out manually. Okay, thank you for watching, and I'll see you next time.